Last lesson we were looking at indices, and you learned these three rules: multiplying, dividing, and the zero power. So this lesson we're going to learn another three rules that will help us simplify and work with powers and indices. The first style that we're going to look at is something that looks like this. So simplify 2 squared in brackets to the power of 3. So let's think about what that cube means there. That cube will apply to everything that's inside the brackets. So if we were going to try and think about what that means, we would have 2 squared 3. That's going to be everything inside the brackets times by itself 3 times. 2 squared times 2 squared times 2 squared. And I look at that for a moment and I think, brilliant, we know what to do with this. We learnt already what to do when we're multiplying powers with the same base, so we just need to use this rule. We just need to add those powers together. So I can write this now equals 2 to the power of 2 plus 2 plus 2. So we're just going to add those powers together. That is going to be 2 to the 6. So I'm going to have a little look at this. I'm going to notice something, because we've had 2 to the power of 2 to the power of 3, and we've come out with 6. And I've noticed that there's 3 lots of these 2's added together. 3 lots of 2, or 3 times 2. We've actually just multiplied the 2 and 3 together to get that 6. And I'm going to tell you that this is true for any number that looks like this. So anytime you have a power inside a power, or I call it a power to the power, we're just going to multiply those two indices together. So an example down below, we've got 3 cubed to the power of 4. That's going to be equal to 3 to the power of 3 times 4. And we can do 3 times 4, that's 12. So it'll be 3 to the 12. Alright, so I've got a couple of questions here just for you to have a little practice using that rule. The first one is quite straightforward, and I think the next two are a little bit harder. So I'm just going to encourage you to pause it and have a think, and then I'll come back and tell you how to tackle these problems. Okay, hopefully you had a chance to have a little think about those, and now I'm going to go through the answers. So the first one, I'm just going to put it in there. We've got y is going to be 5, that 3 is a, and that 4 is b, so it's going to be equal to 5 to the 3 times by 4. And no, that's one we did before. 3 times 4 is 12, so 5 to the 12. Second one. Now this one's a bit different because we've got a number in there and a letter, so we've got 2t to the 4 all cubed. First thing we're going to do, now this is similar to last lesson when we were looking at multiplying with numbers and algebra. We're going to deal with them separately, so I'm going to deal with that 2 first. So I'm going to do 2 cubed. There's everything inside the brackets cubed. I'm going to do 2 cubed, and then I'm going to times it by the t to the 4 cubed. So 2 cubed is 2 times 2 times 2, well 2 times 2 is 4, and then times that by 2, 4 times 2 is 8, so that's going to be 8, 2 cubed is 8, and then I'm going to have t to the power of 4 times 3, and that's going to be t to the 12. So the answer is 8t to the 12. Finally, we've got this one. Now this one looks really a bit scary, but it's actually fine. I think the first step is going to be simplifying that middle bit before we try and do the power outside of it. I'm going to rewrite this now as 3 to the power of 4 plus 2, using that multiplying rule. 3 to the power of 4 plus 2 is going to be 6 to the power of 3, and now it looks the same. So now we can just put that back into this formula, and it will give us 3 to the power of 6 times 3, which is 80. 3 to the power of 18. So really well done if you managed to get those ones already. The second example for today is this question here. So simplify 4/7 cubed. So let's have a think about what that means. Again, I'm just going to write this out how I know what it means. I know what cubed means. It means times by itself 3 times. So let's get rid of those confusing brackets and just write this as 4/7 times 4/7 times 4/7. Okay. Now if you think back to how to multiply fractions out, this will come to 4 times 4 times 4 on the top, and 7 times 7 times 7 on the bottom. And then let's simplify that nicely now. We could write that as 4 cubed over 7 cubed. So 4 over 7 all cubed is equal to 4 cubed over 7 cubed. And this rule is always true as well. And I could argue it in a very similar way for any set of numbers. So this is a rule we can use when we have a fraction to a power. So let's have a little practice. I've got a set of 3 questions here. Have a go at rewriting those. So pause the video and have a go yourself to try and rewrite it using the formula in the corner. Alright, hopefully you had a go at those. I'm going to give you the answers to these now. So the first one, we're just going to pop it in. So we've got 2 fifths to the power of 3. So then we're going to have 2 cubed over 5 cubed. This one looks very similar to the actual formula with just a 4 in place of the a, so we're going to have y to the 4 over x to the 4, and lastly we're going to have 4 to the t over 3 to the t. Okay, so well done if you managed to get those ones. Okay, so that's rule number 2, and the last rule, I said we're going to learn 3 rules today. The last rule is a negative power. Last lesson we did see some negative powers, and I said not to worry about these, and we'll explain what these mean. Now's the time to understand what these mean. So how can we explain what a negative power means? I'm going to try and create this negative power. I'm going to try and make 2 to the minus 5 using the division law and using the 0 power law. So I'm going to write this, and I think if I do 2 to the power of 0 divided by 2 to the 5, that will give me 2 to the minus 5, but I'm going to check that just now, because I think that works. So we have 2 to the 0 divided by 2 to the minus 5. We're going to use our division law. That's going to be 2 to the power of 0 minus 5, and 0 minus 5 is minus 5. So I've definitely made it, but what does it mean? Well, 2 to the power of 0, anything to the power of 0 is 1, we know that. So I'm going to write that as 1 instead. So 1 divided by 2 to the 5. And I'm going to write that as a fraction. So we're going to have 1 over 2 to the 5 equals 2 to the minus 5. Interesting. So 1 over 2 to the 5 is equal to 2 to the minus 5. I want to try and do the same thing with 3 to the minus 2. So let's start again with 3 to the power of 0. So that worked last time. And if I divide that by 3 squared, I think that was going to give me 3 to the 0 minus 2 is, yep, that gives me 3 to the minus 2. And, well, I can do the same thing, can't I? Because 3 to the 0 is 1 divided by 3 squared. And now I can write that as a fraction as well. 1 over 3 squared is equal to 3 to the minus 2. Interesting. So I've got these two results here. I want to have a think for just a moment. How would you explain what 2 to the minus 5 and 3 to the minus 2 means? How would you explain what this means in general? What does a negative power mean? So I think we could explain it like this. So y to the minus a is equal to 1 over y to the a. So anytime you see a minus power, you're just going to do 1 over y to that original power. So let's have a look at some examples. If we use this rule, the first one, 4 to the minus 4, that's going to be 1 over 4 to the 9 to the minus 6. Well, the base is 9, so it's going to be 1 over 9. And then the power, we've got minus 6 here, so that's going to become a 6. 1 over 9 to the 6. Now, this one looks a little bit more complicated, but it just means we've got to do one more step. I'm just going to simplify this first. So I'm just going to do this multiplying. So 3 times 3 to the minus 4, well, 3 is the same as 3 to the 1. So now we can just add the powers together. 1 plus minus 4 minus 3. Oh, and now it looks like we can apply the rule. 3 to the power of minus 3 is 1 over 3 to the 3. Okay, so question 4, we've got some more multiplying. So I can just use the multiplying law again. But wait, I can't because they're not the same base. So if they're not the same base, we can't combine the powers. So I might just leave that 2 for a moment and then think about this 5 to the minus 3. So the 5 to the minus 3 is going to be 1 over 5 to the 3. Okay. And I think what I'm going to do is I'm just going to nicely put that 2 on top there. So it would be 2 over 5 to the 3. And then the last one, same thing again. Look, they're not the same base. We've got a 2 here and a 3 here. So we can't add those powers together. But what we can do is write each one as a fraction. And then we could just times them together. So let's think about how we times fractions. The top is going to be 1 times 1. The bottom is going to be 2 squared times by 3 cubed. And if we want to write this really nicely, we might get rid of that times. Okay. So that's 3 rules that we've learned then today. We've learned the power of a power, we've learned the fraction to a power, and we've learned the negative power. So we now have all of these tools to help us tackle powers and indices. So I want you to have a go at using these on the attached worksheets. I think I find it difficult sometimes to work out which rule I'm supposed to be using. So what I like to do is just have a look and see what looks familiar. So do I see a divide sign? Then I'm going to use a divide rule. Do I see a 0 power? That's nice because I can quickly put that as a 1. So just you're going to be looking at the questions and seeing how you can apply the rules. Alright, so give the worksheet a good go and then take a photo of your work and attach it to the Google Classroom assignment so your teacher can see all the great work that you've been doing.